If you're watching this, it's because you're in my Math 238 calculus class, and we need to learn about implicit derivatives, the last topic that's covered on your test. These are shapes that you see every day, like circles. So how big do we want this circle? So the next thing is radius squared. So if you want a circle of size 1, radius, you say equals 1. You want a bigger circle, like radius of 2, 4. And you know, you can just keep going with squares to make it nice. Next square would be 9. Ooh, that's pretty. Let's go for the next perfect square. 16. Yeah. So you get the point. Uh, so that function, or it's not a function. That's the problem. It's not a function. These things are equations. So by definition, if x gives two possible values of y, then it's not a function, right? Input is not specific. There's multiple outputs possible. Given one input, there's multiple outputs. So in those situations, you need what's called implicit derivative knowledge. All right. So here's how you take the derivative without isolating for x. So implicit derivatives equals when y is not isolated. So here's the setup. We're taking the derivative of each term using the addition rule with respect to x. The question says find dy dx, which is the derivative. This notation is more precise than using, I mean, this means the same thing as y prime, f prime x. Those all mean the same thing, but this one's much more descriptive about what's happening. And I'll explain in a minute. So here I use the addition rule, right? Here I'm using the power rule. And with this notation, you can see the the issue here is that I took a derivative of y and a derivative of x. I have to isolate dy dx. Okay, so this stays as it is, but dx is 1. I don't have to worry about that anymore. Change of x with respect to x is 1. And now in this line, I'm going to change to y prime to denote the derivative, just to save me energy. And now isolate y prime. So the answers here, you'll notice, have both x and y in them. This is a beautiful solution because it shows it doesn't matter the size of the circle. The tangent line can always be predicted using this here. So again, if you put your coordinates into here, now you get the slope of the line at that point. So let's do one more question, and then you can try some homework yourselves. Y cubed, x cubed. In my opinion, this is one of the most beautiful equations. Let's take a look at what that looks like. The beauty here is that if you zoom out, you wouldn't know it's there. It's a straight line. Then when you zoom in, it makes this magical little pin hair churn, just as if it was growing like a leaf. And that's why Descartes liked it so much, is he said it was aesthetically pleasing because it reminded him of a leaf. And you can change the size by making that bigger. But the symmetry is still there. And again, when you zoom out, doesn't matter. Just a knot. It's amazing. Okay, let's take that derivative. Here you have to do the product rule, which will mess some people up. So now you want to put anything with y prime on the left and everything without on the right. And I'll cancel out the threes at the same time. And that's a beautiful answer. The symmetry in that solution is absolutely gorgeous.